Okay, continue. So 3 to the power of 4x minus 2. All I have to do, I look at what they gave me. So they gave me 3 to the power of 4x minus 2. And to simplify this, all I need to do is look at my laws and decide which law applies. So 3 to the power of 4x minus 2, if I look at this law, a to the power of n divided by a to the power of m is the same as saying a to the power of n minus m. And according to this law, saying 3 to the power of 4x minus 2 would be the same as saying 3 to the power of 4x divided by 3 to the power of 2. That's what this rule is telling me. Remember to stop me if you're confused about anything or have any questions, right? The last two, 3 to the power of x minus 3. This same rule applies. 3 to the power of x minus 3, that's the same as saying 3 to the power of x divided by 3 to the power of 3. That's just me looking at my laws and then looking at what the question gave me. But of course, I don't just leave it like this. Remember, the aim is to get 3 to the power of x. Why are we doing that? Because they told us they want the expression in terms of z. So continuing, we know we could simplify this even further. We know that 3 cubed is 27. So I could rewrite this as 27 multiplied by 3 to the power of 3x. So instead of putting the multiplication sign, all I did was put brackets instead. So this is the same as saying this, right? Because 3 cubed is 27 plus 3 to the power of 4x divided by 3 squared is 9. So we do it, we simplifying, right? And then we have 3x divided by 3 cubed, which is 27. So we almost there. Remember, we aiming for 3 to the power of x. We're not there yet, right? We need to simplify until we can't simplify anymore. So I could erase this top part here. I need some space. Yes, no?
Yes, miss.
Okay. So I'm erasing this blue part as well. I will erase the green here. What you need to keep in mind is your aim. Your aim is to get 3 to the power of x. So what again can I write here? Looking at this rule, remember last class, so the rule above, right? Last class, I told you, and I showed you, I proved to you, that a to the power of n, and this whole thing raised to the power m, if I wanted to, I could switch these numbers. So if I said a to the power of m, and this whole thing raised to the power of n, I would get the same answer. So just to show you a quick example, if I had, so I'm using the same 4 squared. So if I had 4 squared raised to the power of 3, if I decided I want to switch these numbers here and instead say 4 cubed raised to the power of 2, the answers I get would be the same. And you could check that in a calculator. So this is supposed to give me this. And this would also give me the same answer. So what I'm trying to tell you is that these indices here, if I switch them, I would get the same answer. So now let's apply that here. So let me use the equivalence. Is the same as, right? I could apply that rule here now. I could say, okay, 27 3 to the power of 3x. That's the same as saying 3x to the power of 3. Okay? If you don't understand how I did that, let me know. So let me just erase some things on the board because it's kind of confusing. Okay, let me continue now. Right. So saying 3 raised to the power of 3x is the same as saying 3x cubed, right? According to my rule. Plus 3 to the power of 4x. Looking at this rule up here, mn. So an nm. In this case, my n would be 4, m would be x. And according to this rule, I could write it as 3 to the power of 4, and this whole thing raised to the power of x, or like I showed you just now, if I switch these, it would give me the same answer. So they're both equivalent. So saying 3 raised to the power of 4 and this whole thing raised to the power of x is the same as saying 3 to the power of x, and then this whole thing raised to the power of 4. For this particular example, I would use this one right here. Why would I use this one? Because our aim is to get 3 to the power of x, and this one gives me the 3 to the power of x. So let me just erase. Instead of saying 3 to the power of 4x divided by 9, I could say 3 to the power of x, and this whole thing raised to the power of 4 divided by 9. And then this one, I already have the 3 raised to the power of x, so I could just leave that by itself. Now, we have an expression where I could substitute the 3 to the power of x with z. And that's exactly what they want me to do. Remember, the question said to write this expression in terms of z. Remember, z is 3 to the power of x. So what I could do now is say 27. I see 3 to the power of x here, so I could replace this with z cubed plus 3 to the power of x raised to the power of 4. That's the same as saying z raised to the power of 4 divided by 9 plus z is 3 raised to the power of x. So I could say z divided by 27. And this right here in the blue would be my answer because they wanted the expression written in terms of z. Everybody understands this?
Yes, ma'am.
Yes, miss.
Okay. So that was, you need some time to write down this because I'm going to clear it off now. Oh, you good?
Miss, I'm finished.
Okay. Right. So we almost finished with indices. Yeah, I plan on finishing indices today. So solving exponential equations. So remember, exponents, indices, it's the same thing, right? So when solving them, these equations, when the bases are the same, the indices can be equated. So what exactly does that mean? If I have a to the power of n is equal to a to the power of n, m, then my indices, I could equate them. So n would be equal to m. This is just an example to show you that. Because, yeah. 2 to the power of x is equal to 64. However, when using this rule right here, the bases are the same. Bases are the same. Please remember that because as you move on to other topics, people get confused with this, right? Sometimes they would see 2 different bases. So you see they're saying 2x is equal to 64. They might say, okay, 64 has a power of 1. So that means 2x must be, x. Hold on. My mouse is giving trouble. Right. So they mix it up. The bases must be the same. But when people mix it up, they might say, okay, 2 to the power of x is equal to 64. 64 is a power of 1. So that means that x must be equal to 1. No, this rule only applies when the bases are the same. Remember that. Bases must be the same. What exactly is the base? You see this letter A here? This letter A represents my base. So these two numbers must be the same for me to equate their indices. Example, solve the equation 2 to the power of x is equal to 64. So I see that 2 and 64, they are not the same. They don't have the same basis. So what I need to do is to make sure that they have the same basis. And what I could say is that 64 can be written to the base 2, because 2 to the power of 6 is 64. So instead of saying 2 to the power of x is equal to 64, I could say 2 to the power of x is equal to 2 to the power of 6. Now I have the same basis, 2 and 2. They're the same. And now I could equate their indices. 2 to the power of x is equal to 2 to the power of 6. What does that mean? X has to be equal to 6. And that would be my answer. Everybody good with that so far?
Yes, miss.
Okay, remember bases are the same, eh? Telling you people, mix it up. Okay, let's try these now. I'll do the first one with you, and then the others, I'll let you try it. Give you some time to do that, and then we would go through it, right? Screen. So they want you to solve this equation. 4 to the power of x is equal to 8. However, I told you when solving exponential equations, the aim is to get the bases to be the same, and then, only then, I could equate the indices. So what I do not do, so this is what I don't do. I don't say, okay, 4x is equal to 8. 8 has a power of 1. Therefore, x is equal to 1. This is incorrect. No, no, no. You will get it wrong. This is the correct thing now. Get the same basis. So 4 to the power of x. Actually, no. Can't do nothing. 4. 4 could be written as 2 squared. So that becomes 2 squared to the power of x is equal to 8. Could be written as 2 cubed. And according to this rule that we just went through, the a to the power of n and this whole thing raised to the power of m is the same as saying a to the power of n m. So all I do here is multiply my indices. So in this example here, saying 2 squared raised to the power of x is the same as saying 2 raised to the power of 2x. How did I get 2x? All I did was multiply these indices, just like my rule says, right? And this is equal to 2 cubed. Now that my bases are the same, so the both of them are 2, I could equate their indices. I could say now that 2x is equal to 3, because those are their indices, and I solve for x. X would be equal to 3 and 2. And this right here is the correct way of doing it. This would be my answer if they asked me to solve. Everybody good with this?
Yes, miss.
Okay. This is not difficult, okay? It's really not difficult. Just remember, same basis. Must be the same basis. Don't be like most people and mix it up, okay? Now I want you to, no, not there again. Now I want you to do number 2 to 4. I'll give you some time to do that. It shouldn't take long though. So like a 7 minutes, 6 minutes. Yeah. You can send me answers on Zoom. So just send me what you get. Or you can send me a picture on WhatsApp. So yeah, do that now. Can I like what they got for this one? What is x equal to?
I got 4.
Miss, I got 4.
Okay, sorry about that, right? So the aim, remember, we need to get the same base, right? 3 to the power of x, that can't be simplified any further. So we know we just leave this 3 to the power of x. But how can we write 81 so that I get the same base? How do I write 81 to the base 3, right? 81 is the same as 3 to the power of 4. So now that I have the same bases, 3 and 3, I could equate the indices. Therefore, x has to be equal to 4. This answer is correct. So you see, it's easy thing. Nothing too difficult. Let me erase this. Next question. 9 to the power of x is equal to 243. Can anybody tell me what answer they got for this one?
Miss, 27.
How much?
27.
77.
No, Miss, 27.
27. Okay. And you want to tell me how you went about to get that answer? How'd you get that answer? Okay. So let me show you something. If I say, okay, 9 raised to the power of x, you might say, it might be possible for another question. Okay, if I have this to base 9, maybe I could change this to base 9 as well. However, that's not possible. Why? You might be wondering. 9 raised to the power of 1 is 9. Okay, 9 squared is 81. Okay, so you might say, maybe 9 cubed would give me the 243. But no, 9 cubed gives me 729. So this is how we know, okay, the base I'm looking for is not going to be 9. I need something smaller than that. So what base can I write the both of them to?
Miss, 3.
So all of this you have to be thinking about when you're doing your question. So 3 squared is the same as 9. So I could say 3 squared raised to the power of x is equal to 3 raised to the power of 5 is going to give me 243. We know that this is 3 raised to the power of 2x. If you don't understand that, let me know, right? 3 to the power of 5. And now I could say, okay, I have the same basis, 3 and 3, so I could equate the indices. Therefore, this is the therefore symbol, 2x has to be equal to 5. However, we don't just stop there. Why? Because we're solving for x. 2x is equal to 5. Therefore, x has to be equal to 5 on 2. So, you understand where you went wrong?
Yes, Miss.
Okay, cool. That's what's most important. It's okay to make mistakes now, just once you understand where you went wrong. Can I erase this now?
Yes, Miss.
Okay. Okay, let me just click the whole thing. Last question. 16 raised to the power of x is equal to a half. That's what they gave me. They want me to solve for the value of x. Can anybody tell me what answer they got for x? Going once. Going twice. Okay, so x is a mystery. We do not know. But that's fine. We're here to learn. So now I need to determine what base am I going to use. 16. Can I use 16? Can I write a half to the base 16? No. Okay. So what else can I do? What other base can I use? Maybe a 4. I don't
Miss,
know.
a 4.
Maybe use 4. You use 4?
Yes, Miss.
Okay. So what did you get? Okay, so you have this first line. What was your second line then?
4 to the second power, close bracket, to the power of 8.
Okay, I have no idea what you just said. Repeat.
4 to the second power, to the power of 8.
And then 4 to the power of 8. That's what you tell me.
Repeat me.
What did you have for this side here? This is what you had for this side, right?
Yes, Miss. I didn't get to work out the rest of it.
Okay. Well, this is actually, wait, is it a possibility? Hold on. I didn't use 4. But let me see if it's actually a possibility. Could be. Okay, so I'm not guessing this to be a possibility. So that means that 4 is not the base we're looking for. If 4 is not the base we're looking for, then we know that it has to be a number that's smaller than 4. What other number can I use? I can't use 3 because that wouldn't give me the 16, but I can use 2 because 2 to the power of 4 is going to give me 16. I'll double check the base 4 for you though, because it could be a possibility that base 4 works. I'll just have to check it. So right now using base 2. So 2 to the power of 4 is the same as 16. So okay, 2 to the power of 4, and this whole thing raised to the power of x. But how exactly am I going to write a half to the base 2? These are questions you would be asking yourself. Well, we know a law that says a to the power of minus n is going to give me 1 to the power of a n. We know that 2 is the same as saying 2 to the power of 1. Why? Because we also know this law that says anything raised to the power of 1 is going to give me itself. So that's why we could say 2, if I have 2, that's the same as saying 2 to the power of 1. And that's why I just added that power there. So now back to this rule. This rule, according to this rule, 1 over 2, so a half, I could rewrite that as 2 to the power of minus 1, just according to this rule, right? This is 4x. Please let me know if you don't understand how I got 4x is equal to 2 to the minus 1. Now that we have the same basis, we can equate the indices. Therefore, 4x is going to give me minus 1. Therefore, oh gosh, wait, that's too many therefores. X is going to be minus a quarter. Everybody understands this one?
Yes, please.
Okay. I will double check the base for you though, but I don't think it would work. It's a possibility though. Can I erase this now? Yes, no?
Yes, miss.
Okay. Escape. So that's that there. That's the baby stuff. Okay. Now on to the more advanced equations. The advanced exponential equations. Do not get frightened. It's fairly simple once you know what you're doing, right? That's what I'm here for. Right. So example, solve the equation 2 to the power of x plus 1 minus 3 times 2 to the power of x minus 2 equals 0. So step 1, use substitution to reduce the equation to its linear or quadratic form. I just want to show you one thing. Look at your syllabus objectives. Equations reducible to linear and quadratic forms. So that's where we are right now, right? According to this, you see those exponential equations I was showing you, those ones we were doing just now, they can be reduced, so they can be rewritten into linear form or quadratic form. So we did this already, linear form, that would be this form. So y is equal to mx plus c. Quadratic, or you might see a y is equal to mx. Quadratic, the quadratic is this form, bx plus c. So that's what they mean. The equations can be reducible to linear or quadratic forms. So let's just go back to what we were doing. Use substitution to reduce a quadratic to its linear or quadratic form. So this is what we have. Substitution. We went through the substitution method already, right? So if you need to review it, Google Classroom. This is what they gave us, the equation, and we could simplify this. 2 to the power of x plus 1, that's the same as saying 2 to the power of x multiplied by 2 to the power of 1. Just in case you don't understand how I got that, it's because I used this rule. A to the power of n multiplied by a to the power of m is equal to a to the power of n plus m. And that's how I was able to tell that 2 to the power of x plus 1 is the same as saying 2 to the power of x times 2 to the power of 1 minus 3 times 2 to the power of x minus 2 is equal to 0. I could rewrite this. So instead of putting this multiplication sign, I just put brackets. So this is the same thing. 2 in brackets 2 to the power of x minus 3 in brackets 2 to the power of x minus 2 is equal to 0. This is where the substitution comes in. You let y equal to something, right? So in this case, you would recognize that you have 2x here, you have 2x here. So using the substitution method, I could say let y, or doesn't necessarily have to be y, you could use any letter you want to use. So you could say A, B, Z, H, whatever, right? I just decided to use y. So I said, let y equal to 2 to the power of x. So instead of writing 2 to the power of x now, I could write this equation as 2y minus 3y minus 2 is equal to 0. All I have to do now is solve for y. 2y minus 3y, that's going to give me minus y, minus 2. And then I solve for y. Hold on. Minus, this should be plus. This should be plus, 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 plus. All right, so this should be y minus y plus 2 is equal to 0. So minus y is going to give me minus 2. And that's why y is going to give me 2. So my bad. Just change that minus sign to a plus sign, please. Okay. So step 2 is to solve the exponential equation. So now that we know, remember we said, hold on, let me just erase all this. Remember we said that we're going to let y equals to 2 to the power of x. So now that we know that the value of y is 2, I could say, okay, since y is equal to 2 to the power of x, and my value of y is 2, I could rewrite this as 2 is equal to 2 to the power of x, right? And remember, when solving exponential equations, I must have the same base, and then, only then, can I equate the indices. So 2 is the same as saying 2 to the power of 1, and then we have the 2 to the power of x. Bases are the same, so that means that x has to be equal to 1. And that's how we do that. You good with that? Or you need me to re-explain something? Just let me know.
Yes, seems good.
Okay. So just in case you didn't know, this would be an example of the linear one, right? Sometimes you might, instead of getting this, which is the linear form, so all you have to do is, okay, carry across the 2, y is equal to 2. Okay, yeah, that's nice, easy. Sometimes you might have a quadratic, and you would have to solve the quadratic. Remember, there are 3 ways to solve quadratics: the formula, factorization, or completing the square. But usually, what most people go for is the factorization, because it's the shortest method, right? Okay, so now we're going to try these two. I want you to try it first by yourself, just to see if you could get it out. And then I will go through it with you. So I'll give you like 5 minutes just to do the first one. If you finish the first one before I'm ready to go through it, by all means, do the second one. Nobody's stopping you, right? So just attempt these, and then I'll go through it with you. Using the same steps from before. So if you want me to go back to the other slides, just let me know. Just write down the question and I'll go back so you can see the steps for you to follow.